Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 6 on constructing reflections. So throughout this unit we've been working on a variety of constructions including parallel line constructions, perpendicular line constructions, angle bisector constructions, and a variety of others. Throughout all of these, we can use some of these constructions to help us create some of the rigid motions that we looked at, especially in Unit 2. So let's jump right in and see how we can construct the reflection of a point across a line. All right, line reflections. Now that we can construct a perpendicular from a point to a line, we can go one step further and construct the reflection of a point across a line. First, recall the following definition of a line reflection. The geometric definition of a line reflection. When point A is reflected across line N, it and its image point, A', form a segment A' such that the line N is the perpendicular bisector of segment A'. In other words, N, the line of reflection, is perpendicular to the segment A', and AM is the same length or equal to A'M. All right, so real simple, right? The idea of any line reflection, keep this in mind because it's going to be the key to our construction, is that whatever this point is, when it gets flipped across the line, two things are true. One thing is that it's simply the same distance on one side of the line as it is on the other side of the line, and that distance is a perpendicular distance. In other words, that line of reflection is perpendicular to the line that connects the point and its image. So let's see how we can use that along with tools that we've developed in previous lessons to reflect a point across a line. All right, here we go. Exercise number 1. Given line N and point A shown below, do the following. Letter A, construct a line passing through A that is perpendicular to line N. Label this as line P. Okay, great. So we know, right, that when we connect the point with its image after the reflection, right, that line segment will be perpendicular to our line of reflection. So the first thing I'm going to do is construct a line that passes through A that is perpendicular to N. This is one of the last lessons that we actually did before this one, so let's recall how we do that. The first thing I'm going to do is I'm going to bring my compass over to point A, and I'm going to construct an arc that is centered at point A that passes through line N twice. All right, very, very important. So I'm creating this arc so that it passes through line N twice. Now what I'm going to do is I'm going to bring my compass down and put the center of my compass right at one of those intersection points, and I'm going to draw an arc below the line. Then I'm going to switch my compass point, get my ruler out of there, so that it's at the other intersection point of the arc and the line of reflection. And I'm going to draw another arc. I'm going to try to keep the point on that. There we go. All right. Accuracy is really key here if you want a good construction. And now I'll bring my ruler over. That point and point A must lie on that perpendicular. Right away, I've got it a little bit wrong here. Now in theory, that line should be perpendicular to those. And now I will draw that through. And I'm going to label that line P. And I'll maybe draw it a little bit above as well, although I don't really need that. All right, so we now know that that line is perpendicular to line N, right, and passes through point A. So somewhere along this line, obviously on this side, the image of A has to lie. So now let's keep taking a look at our directions. Letter B. Along line P, use your compass to locate A' on the other side of N such that it is the same distance from N as point A. This is the reflection of A across line N. This is the traditional method for performing a line reflection. All right, and as you probably can guess by this last statement, we're going to see another method later on in the lesson for reflecting points across lines, but this one makes a lot of sense, right? The first thing I'm going to do is just draw a perpendicular line through that point, right? through the line of reflection. Now I'm going to use my compass. I'll bring the compass up. I'm going to put the compass point on the intersection of my perpendicular line and my line of reflection, and I'm going to measure the distance that A is away from my line of reflection, right? And I make my arc like that. And now what I'll do, now that I've got my compass length set, is I'm going to rotate it all the way down to here, and I'm going to measure the same distance, right? Therefore giving me that essential quality of a line reflection, which is that the point ends up, the image point ends up being the same distance, right, on one side of the line reflection as it was on the other side. Now, critical, to, of course, to this construction is the idea of constructing a line through a point perpendicular to another line. Okay, that's going to be the big piece. Just like when we constructed translations, the big piece was constructing parallel lines. Here, the big piece is constructing a perpendicular line. All right, let's keep working on these types of constructions. Reflecting geometric objects. Now, we can certainly reflect more than just a single point. Since this construction is relatively involved, to accurately reflect even a line segment requires time and careful work. So let's try that in exercise number 2. Using only a straight edge and rule, construct the reflection of QR across line M shown below. Leave all construction marks. All right, simple enough. So I want to do exactly what I just did, except I want to do it twice. I want to reflect point Q across line M and reflect point R across line M. So what I'd like you to do is, well, actually, let's do one more of them together. Let's reflect, let's say, point Q, and then we'll have you work on point R by yourself. So let's do it. Let's go through that construction one more time. I'm going to bring my compass over. Remember, I start by constructing a line that passes through Q that is perpendicular to line M. And the first thing I do when I do that is I have to draw that arc. Let me get my ruler out of the way. I have to draw that arc that is centered at Q and that passes through my line twice. All right, just did it. Excellent. Okay, so now that I've got those intersection points, I'm now going to come down here, maybe make my compass a little bit wider. It can be the same length, but there we go. I'm going to draw that arc, and let me get this one in. Of course, I keep losing that. That'll make it easier. There we go. Draw that arc, and now X marks the spot as always. Move my compass out of the way. Point Q and that intersection point are going to lie on that perpendicular line. So now we draw that perpendicular line. I always like to extend it quite a good distance. Now I need to simply measure the distance that Q is away from my line of reflection using my compass. So put the sharp point. Try to get that sharp point right on that intersection. There we go. And now measure that distance. That's not too bad. Bring it down here. Make the same mark. And we've got the location of Q prime. All right, we've got Q prime. Again, construct a line that passes through Q perpendicular to line M, right? That's our blue line here. Then use our compass to measure the distance from line M to point Q, reproduce that distance on this side of the line, and we locate our image point. All right, what I'd like you to do is pause the video now and see if you can also find the image of point R after a reflection across line M, and then connect Q prime and R prime to construct the image segment on the other side of line M. All right, let's do it. Here we go. Bring my compass up, put the center at point R, maybe stretch this open a bit. A little more. I think that's going to be enough, but I always want to make sure. I think I'm going to make it a little bit wider. Okay, that'll definitely pass through the line twice. Very good. Bring this up like this. Put my point centered there. Make an arc. Oh, come on. Just got to get the point right on there. Make another arc. Excellent. Those two arc intersection points will then allow me to draw this line. Maybe make it a little bit longer. And now let's find where R should be located. Scroll up a little bit more. Flip this thing, bring it open. Oh, so close, come on. There it is. Oh, pretty much right on the money. Swing it around. Oh, wow. Now that sometimes happens, by the way. That's complete coincidence that where those two original arcs were intersected also ended up more or less being the location of R prime. And now the only thing I need to do is connect the 2 points with a straight line segment. And there we are. All right, let me move that out of the way so that we can get a good look at it. And it looks right? It looks right. In fact, this line and this line are parallel to each other because they're both perpendicular to the line of reflection. And actually what we get almost always when we reflect a line segment across another line is something that looks like a trapezoid, right? In fact, it doesn't just look like a trapezoid, it is a trapezoid. Okay, so let's keep going and start to think about an alternative method. We're going to do this construction one more time, but the next one is going to lead up to our sort of method 2, if you will. Let's take a look at exercise number 3. Given triangle EFG shown below, do the following. Letter A, using a straight edge and compass, construct the reflection of point G across segment EF. Label its image as point H. Okay, so sometimes you have to do sort of constructions within a larger picture. So here what we're looking to do is we're looking to reflect point G across segment EF. Why don't you pause the video right now and see if you can do that construction. All right, well this is no different from what we've been doing. We just have to, do it within this context. So let's go ahead, right? As always, the first thing I'm going to do is I'm going to put my compass point right at G. Open up that compass, right? I've got to get it big enough that it's going to end up giving me 2 intersection points. That should be good. Just barely, but I got it. Okay. Now we're going to move our compass here. And let's see if we can get that compass to stay on that intersection point. There it is. Maybe flip it around now like this. Bring it up. Get that other intersection point. Ooh, that's got to be uncomfortable for the compass. Let's bring it back like this. Maybe shrink my ruler down a bit. And let's draw that perpendicular line. Almost there. Constructions. They always take some time. So now we've got a line segment that is perpendicular to EF that passes through G. We just now have to figure out where the image of G is. So we will measure the distance from our line of reflection to the point that we're trying to reflect. All right, that might be as good as I'm going to get, but let me try just a little bit better. Okay. All right, had to miss a little bit there due to the limitations of my technology, and there it is again. I keep making it so that it's right on the money, which is kind of killing me. But what are we supposed to do? We're supposed to label its image point H. Great. And there we go. Right? We have found the location of our reflected point, the image point. Now again, this was another coincidence where basically the distance ended up being exactly where those 2 arcs were, which won't always happen, but did a couple times in a row. What are you going to do? All right, anyway, let's take a look at letter B. This is simple. Draw segment EH and segment FH. All right, that's simple enough. Why don't we just go ahead and do that together? Nothing to be too stressed out about. We're just going to draw in segment. Nothing too stressed out about, and yet I can't get it to rotate. Okay. There is our EH. Can't seem to get the ruler to move. I can get it to rotate. There we go. And there is segment EF. Okay, so simple enough. But now let's see what the point was of doing that. Let's take a look at letter C. Explain why triangle EHF must be congruent to triangle EGF. All right, well, this really takes us back to Unit 2 and to Unit 3, right? I want to know why triangle EHF, really the triangle I just drew, must be congruent to triangle EGF. Pause the video now and see if you can give any reason for that. All right, well, it's pretty simple actually. Triangle EHF is just the image of triangle EGF after a reflection across EF, right? That's it. And because reflections are rigid motions, the two triangles must be congruent. So we're just going to get all that down, right? Triangle EHF is the image of triangle EGF after a reflection across EF. And let me throw this in. Since reflections are rigid motions, the two triangles must be congruent. All right, that's it, right? So EHF is the image of EGF after a reflection across segment EF. Since reflections are rigid motions, the two triangles must be congruent. Anytime one geometric figure can be mapped onto another geometric figure using either a reflection, a translation, or a rotation, right, our three basic rigid motions, then those two geometric objects must be congruent. All right, let's start taking a look at another method. I call this the kite method of reflection. All right, let me get this thing out of here. Let's take a look, right? There's another method for reflecting points across a line that takes advantage of the properties of kites, right? Kites are a very interesting geometric object. Even though they're not parallelograms, they're still kind of cool objects. So let's take a look at kites and how we can use them to do a point reflection, or sorry, a reflection of a point across a line, which is not the same as a point reflection. My bad terminology. Let's take a look at exercise number 4. Given line K and point M shown, do the following. Letter A, plot 2 points on line K on either side of M. Mark these points as points A and B. Parentheses, strictly speaking, the 2 points could be anywhere on K. All right, so in other words, what I want is I want to put a point, I don't know, maybe here, and another point maybe here, okay? In the future, we're not going to even label these A and B. All right, I'm just labeling them A and B so that we can kind of talk about what's going on later on, and we don't have to refer to those as just those 2 random points we just plotted. Okay, let's take a look at letter B. Draw an arc with a center at A through M that passes below line K. All right, so in other words, what I want to do right now is I want to take my compass, I want to put it center at A, and I want to then draw an arc that passes through M. In other words, it's going to have a radius of AM, all right, and extends below line K. All right, so that's it, right? Just an arc centered at A that passes through M and goes all the way down here. Now, letter C. It's so hard to get these things so that they're not in the way. Draw an arc with a center at B that passes through M below line K such that it intersects the arc from B. Mark this intersection point as point N and then draw in segment MN, AM, BM, AN, and BN in order to see the kite. Okay, so let's do all of that. So in other words, we're going to do exactly the same thing that we did before, except we're going to have our we're going to have this thing centered at B, or the arc is going to be centered at B. This is going to be very hard to get this in here. All right, but we'll get it. There we go. That's a little bit better. All right. This is where it's going to be much easier for you than it is for me. But I think I've got it about as good as it's going to get. Not quite through line M, but it's as good as I can do it. Okay. Now, it told me to label this as point N and then draw in all sorts of segments. So one thing it wanted me to do is it wanted me to draw in MN. So I'm going to draw in that segment. Oh, that was actually pretty good. I'm draw in segment MN. I'm going to draw in segment AM. I'm going to draw in segment BM. All of that is pretty easy because of how my electronic ruler works. Then I want to get point AN and point BN. Almost. And there we go. All right. There we have it. And we can kind of see the kite shape, right? The kite is AMBN, right? With sort of like this diagonal, AB, and this diagonal, MN. Now, let's get to the thrust of all of this. You probably won't be surprised to know that N, right, the intersection point of those two arcs that we just drew, is the reflection of point M across K. But let's understand why that is, right? Let's take a look at letter D. Explain why N must be the image of point M after a reflection across line K. Okay, so I'd like you to pause the video for a moment, and I'd like to see if you can figure out why that is, and then we'll go through it in some detail. All right, well, let's talk about it a little bit. First, notice that M and N are on the same arc that is centered at A. That means that AM and AN must be the same length, right? Those two have to be the same length. Now notice well, right, that M and N also lie on the same arc that's centered at B, which means BM and BN are also the same length. Now they're not the same length as AM and AN. They could be, but they certainly don't have to be, but they are the same length as each other, right? Now what does that tell you? That tells you that point A is equidistant from the endpoints of MN. And that means point A must lie on the perpendicular bisector of MN. Likewise, B is equidistant from the endpoints M and N, so B must also lie on the perpendicular bisector of segment MN. And that means that if A and B lie on the perpendicular bisector of MN, then in fact, right, K is the perpendicular bisector of MN, and N, right, is the image of M after a reflection across line K. So let's get that down. We won't be that wordy, right? What we're going to say is that both A and B lie equidistant from the endpoints of segment MN, so must lie on its perpendicular, I'm never going to get this in, perpendicular, I guess I did, bisector. So, since line K, let me extend a little bit, is the perpendicular bisector of MN, N is the image of M after a reflection across line K. Sneaky. It's sneaky, right? But the whole idea is that when we have a kite, right? A kite is any figure that looks exactly like what we just had, that has two pairs of congruent sides that are adjacent and don't overlap. In other words, these two sides are adjacent, these two sides are adjacent. It's like taking two isosceles triangles that have equal length bases and just kind of sticking them together, right? And then what happens is that because this line is then the perpendicular bisector of this particular segment, then these 2 points are each other's reflections across that particular line. And that is a very quick way to actually do a reflection of a point across a line. I mean, if you think about our previous sort of traditional way of doing it, we had to draw an initial arc, then 2 more arcs, and then 1 more arc after that, right? So that was a total of 4 arcs in order to locate our image point. Here, we just have to draw 2 arcs, and that's absolutely it. So watch how much easier this makes certain constructions. Let's take a look at exercise number 5. Use the kite method to construct the image of triangle QRS after a reflection across line A. All right, this is cool. Now again, what I have to do is I have to just mark 2 points on this particular line. All right, it really doesn't matter where they are. I tend to put them on sort of either side of whatever I'm trying to reflect, whether it's a point, a line, a segment, a triangle, it doesn't matter. So my first step always when I do the kite method is to just sort of put these 2 points down. So I'm gonna draw these 2 points. You could label them A and B if you really wanted to, but you don't have to. All right, now once I do that, what I'm gonna be doing is I'm gonna be drawing arcs that are centered at this point and this point, that then also go through these 3 points and kind of go below the line. So I'm going to start over here. All right, let me flip this, open it up. And let's just do this method just for point Q. All I wanted to do was get the ruler out of there, and nope, it's going to like continue to plague me. Let me just put it down there. All right, so I end up getting as close as I can to point Q. That's going to actually be pretty good. Not great, right? And then what I'm going to do is I'm now going to put the compass at this point. Oops. Go up a little bit. Come on, there we go. Close. There we are. Right? And where those 2 arcs intersect, that's point Q. Okay, now believe it or not, you could draw 2 different points and then do it with S, and 2 different points and do it with R, but you might as well then just stick with those 2 points. What I'd like you to do now is pause the video and see if you can locate point S prime and point R prime using this method, and then draw in triangle Q prime, R prime, S prime. Pause the video now and take a few minutes to do that. All right, well, since I've got the compass already with the center at this particular point, I'm going to draw those 2 arcs without moving my compass. Or I'm going to try. Boy, I just could not get it very well on point S. And of course, that's going to mean, oh, my goodness. I just had to draw one where like point S and point R are essentially the same distance away. That'll have to do. All right, now what I'm going to do is switch that around. And let me bring this up and get its distance to S. There we go. That's going to be S prime. Now let me figure out where R prime is. A bit better. And there is my R prime. And now we just need to connect them. So let's do that. I always love the final pictures, even if I've kind of botched the construction a little bit, which is pretty easy to do. But I love the look of a reflection, especially of a triangle across a line. You know, it's very, very satisfying. And again, think about how quick that was, even compared to when we reflected that single line segment back in exercise number 2. This was much, much quicker. Again, I had a little bit of an issue at point R and S when I was using this point, simply because these 2 points were essentially the same distance away from that point. They weren't quite the same, but that's why I have those 2 arcs very close together. So we've got these 2 methods for reflecting a point across a line. Let's summarize, right? There are 3 primary rigid motions, right? Translations, we've already seen how to construct those using parallel lines. Reflections, which the key there is perpendicularity, and rotations, which we're going to get into in our next lesson. But the real key to constructing reflections, right, using the traditional method, is drawing that line that is perpendicular through a point to the line of reflection and past it, right, and then just using our compasses to figure out the distance that the point should be on one side of the line of reflection compared to where its pre-image was. We can also use that kind of subtle method, right, where we plot sort of 2 arbitrary points on the line of reflection and then use the geometry of kites to actually figure out where the image point should be. All right, so constructing reflections, something that you want to get good practice on, both with the traditional and the kite method on the homework, and then we're going to move on to doing constructing rotations in our next lesson. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.